going to represent rational numbers on a number line. So we're going to need to do some more definitions. We're going to define rational numbers this time. We're going to talk about ordering rational numbers on a number line. So we're going to look at a Frere model first, look at some examples of how you actually do this, and then there will be some problems for you to practice. So, Frere model for a rational number. We're going to start off with the examples as we usually do. You'll notice we have a bunch of different values here. We have negative 45, we have 0, we have 1/2, 0.23, we have 0.256977888, and we have 34.76, and you'll notice that the 6 is repeating on and on forever. I'm not going to tell you just yet what all of those numbers have in common, but those are all rational numbers. You'll notice that there are lots of different ways that a rational number might look. As for non-examples, we have things like 5.9689, and then it just keeps going. Because it's got the dots, that means it's never going to repeat itself. It's just going on and on and on forever, without any patterns. We have also some very famous numbers like e, which is 2.7 something or other, and then pi, which is, of course, 3.14, and then it also keeps on going on forever. So, based on the examples and non-examples, take like 30 seconds to think to yourself, well, what is the difference between the two? What would make a rational number versus something that's not a rational number? As for the characteristics and facts, a rational number can be any integer number. You'll remember those from our last video. That's any whole number or 0. A rational number can be any fraction. It could be 0, again, or it could be any decimals that repeat after some point. They have some sort of pattern, or they just straight up end. But the key thing to remember here, and if you want to, when you're writing this down, put a star next to it, circle it, put something next to it that you're going to remember, because we're going to be talking about rational numbers a whole lot this year, is that it can be written as a fraction. That is the key thing that makes a rational number, is that it can be written as a fraction. That kind of leads into our definition, our official definition. A rational number is any number that can be written as the quotient of two integers. That just means that it can be written as a division problem to begin with. Anything that can be written as a fraction is essentially just a division problem. So that's going to be our official rational number. All of the examples can be written as fractions. That 0.256977888 doesn't look like it, and it'll probably be a really, really weird looking fraction, but it can be written as a fraction, even if it's not the most ideal looking fraction. The non-examples, none of those can be written as fractions of two integers. It might look like they might be able to, but there's no such way that we can make them into fractions of integers. So in terms of ordering rational numbers on a number line, let's start with the ones that we definitely know how to do. So we're going to start off with the integers, since we worked on those in the last video. If we need to figure out where our first number is, well, that's just a 1, so we're going to put it right here at 1. We have a 0, that's an integer as well. We can put our 0 here. And those are only two integers. We have a bunch of other numbers, but let's just start with there. So, if we look at 0.25, we can think to ourselves, how does that compare to 0? And you may at some point have seen two symbols. They're called the less than and greater than symbols. And we can use those to help us compare these two numbers. In this case, we know that 0.25 is going to be greater than 0. So we're going to use the greater than symbol. Now, the best way to remember which one of these is which is that if you think of the symbol as an alligator mouth, you can think of it as the alligator always wants to eat the bigger number. So since 0.25 is the bigger number, we're going to have our mouth pointed towards the 0. We also know that it's going to be less than 1, so that means that our 0.25 needs to go about there. And that's not perfect, but it gives you the idea of where it's roughly supposed to go. So we've done that one. We can cross that off. We can cross off the other ones that we've done as well. And then we have a bunch more to do. We have 1.5. Again, we can compare things. 1.5 would be about here. It's not perfect. That's a little bit higher than 1.5, but that's okay. We have negative 5/6. That's not going to be a whole number, so it's going to be right here. It's still actually greater than -1 because it's closer to the positive end of our number line. So we can put negative 5/6 right here. And you'll notice I'm labeling all these points as we're going through them. That is super, super important to do because otherwise there's no way that you could say, oh yeah, this is 5/6. It's just something close-ish to -1. 4.5 and -4.5, if you watched the last video, you'll remember that these are opposites. They'll be the same distance from 0. 4.5 is going to go right in between 4 and 5, which means -4.5 has to be the same distance. And one common mistake people make is they will try to put -4.5 right here because they expect it to be to the right of -4. When we're dealing with negatives, if you have a more negative number, you're going to need to go to the left of the previous thing. So we've done both of those. That just leaves -6.7. Again, common mistake would be to try to put it here. But remember, this is actually closer to -7 rather than -6, so that means it's going to actually have to go over here-ish. And now we have plotted our 8 points. So now you're going to try a you-do. There are another 8 values here. Some of them are the same, some of them are different. You are going to plot them on your own number line. Make a new number line, that way you can tell where all your numbers are supposed to be. Ready to go. So, some things to remember. A rational number is any number that can be written as a fraction. Sometimes we joke about getting math things that you need to remember for always because they're super important tattooed on yourself. This is one of those things that you could get a tattoo of. Rational number is any number that can be written as a fraction. You can order your numbers on a number line from least to greatest. And remember that you can use the less than, greater than, and even equal signs to compare numbers. That'll greatly help you figure out where they're going to go on the number line. Finally, some suggested practice problems. We have a few rational numbers for you to place on a number line there. Again, make a fresh number line, make a new one. And then the other one, you have 6 values. You're going to compare them using the greater than, less than, and equals signs. Ready, go, good luck.